The endearing promise of 3D printing is, if you can imagine it, you can make it reality. That obviously skirts around the little step of actually designing the thing, but it's the notion that brings so many makers to the world of 3D printing. Not only can you print the show-stopping parts of your creations, you can also 3D print the nuts and bolts of it. Literally. However, putting 3D printed bolts and screws under strain can result in disaster. In this video, I'll be taking you through a couple of simple tweaks you can make that will produce impressively strong 3D printed screws that won't buckle under pressure. So, let's take a look. With CAD packages like Autodesk's Fusion, it's super easy to create custom 3D printable screws these days. Once you've got your object designed, simply hit Create, then Thread, and select the surface that you'd like to add the thread to. Making sure you've ticked Modeled, just select the thread type you require. Before confirming, if you're going to be making similar screws, or if you're going to be making nuts or female threads, tick Remember Size, and next time you apply the thread to something, it will default to the same thread specs as this. It's as simple as that, and they're ready to print. However, it's not quite as simple as that. They did print absolutely fine, and they do screw together. But if I was to screw this screw or bolt into this nut, and then significant force was placed either on the screw or on the nut in either direction, the screw could just break. This is because when pressure is applied up or down either to just the screw or just the nut, causing a shear point where they meet, or if it's pulling the screw and nut apart, the stress is perpendicular to the layer lines. Between two layers is usually the weakest point in a print, as rather than a single extrusion, it's effectively two parts that have been stuck together. As a result, if enough force is applied, it will force your part to break between your layer lines, and increasing your infill percentage will only help so much here. Now, this often isn't an issue if you have both good layer adhesion and your screw isn't going to be under significant strain in either of those directions. But when strength is a priority, this is an unnecessary and avoidable weakness to introduce to your prints. The reason that this is an issue is because the screw was printed vertically. This makes sense, as to print it on its side or even at an angle would require a significant amount of support. Not only would this mean it would take longer and use more material, but unless you're using a specialist support material, the first layers printed on top of the support are also printed with a thin Z-gap, which would result in poor layer bonding for the first few layers above the support. There's a lot you can do to improve layer adhesion, but the two simplest things that you can try if you're having layer adhesion issues and you're sure your filament is dry is to slightly increase the print temperature, try 5-degree increments until you get a good print, and to slow down the print speed. This ensures that the material is more malleable as it's being pushed down into the previous layer, and that the force that is pushing it down is applied to each area for longer, allowing more time and energy for the bond. If you're designing your screws yourself but you find that they're fitting together very tight, you can add a little tolerance to them by using the press pull tool in Fusion to push in the threads by 0.1mm. Do this to both the male and the female threads and you'll introduce a tolerance allowing them to fit better. As well as to the front of the threads, you can also apply this to the top and or bottom of the threads if needed. To overcome the layer line strength issue, the solution is quite easy. We're going to print the screw on its side, but we're going to slice off part of the screw lengthwise to give it a flat base to print on. I'd suggest removing 20% of the screw based on the diameter of the screw shaft, and you can either do this in the CAD software when designing it, or directly in Bambu Studio and most other slicers using the cut tool. Now we can print this on its side, it means that the strength is in the orientations that you actually want for a screw, as the only weak angle regarding layer lines is now down the centre of the screw, which isn't how pressure would be applied to the screw. It also means that there's no overhang on the thread, and because taller objects usually take longer to print than wider ones, it's not only stronger and cleaner, it's also quicker to print. Now you may be concerned that as it's no longer a full screw, it's either going to be weaker or it won't screw in. But as the original thread was designed whole, everything still lines up perfectly, and as the female thread is a cylindrical shape, and we only cut away 20% of our screw, it's held in the right position without issue. As for strength, for the reasons we discussed earlier, these can be significantly stronger than a vertically printed screw. In a weight limit test, the vertically printed screws broke after just 7 kilograms were applied, but the horizontally printed screws were still going at 15 kilograms. Now remember, I was able to snap the vertically printed screws just with my hands, whereas the horizontally printed ones were still going strong whilst holding more than double the weight that had snapped these. I printed both of these with the exact same print settings, but what I didn't tell you is there's one exception. The vertically printed ones were printed with 30% infill, whilst the horizontally printed ones were printed with just 15% infill, meaning that these are orders of magnitude stronger whilst using half the amount of infill. So, this solution for producing a strong 3D printed thread? Simple. All you need is to have a hot, slow, sideways screw. This has been a quick look at the importance of object orientation in 3D printing. I was thinking of doing a more substantial video looking at the benefits and drawbacks of different orientations with different style prints, so let me know in the comments if that's something you'd like to see. I really hope you found this video interesting and useful, and if you have, please do hit the like button and hype, it's always really appreciated. Don't forget to subscribe so you don't miss out on my future tutorials and deep dives on 3D printing and Maker Tech. As always, thanks very much everyone, and until next time, happy printing. A huge thank you to my revolutionaries, my channel members, for your support. If you'd like to join them, getting early access to my videos as well as other goodies and supporting me, hit join below any of my videos. For now, why not pop on one of my other videos to learn something new or have some fun. Thanks very much everyone, and until next time, happy printing.